We're live.
All right, so were there any questions regarding the reading today, the random or the mean discrete probabilities?
No, I didn't.
Well, I understood it last night, but it's foggy today.
Okay,
Sorry.
that's okay. I mean, look, all the questions we're going over will be about it, so hopefully that'll refresh memory.
Well, I did go through the quiz, and I think I've got it.
Cool.
Okay, sweet. We'll just go ahead and start the quiz then and go down it, starting at question number 3.
Okay. The blood types and the portions given in the table above define probability distribution. I put true.
Yeah, I agree. It's between 0 and 1, and when added up, it's not above 1. So,
correct.
And the third one follows if the first two are true.
That's what I thought.
Cool.
The next question asks, what is the probability that a random selected person in the United States has type O blood? With that, are you just taking the type O blood proportion? Or are you actually doing some dividing?
I just put it like how it is. It says O, and I put 0.45.
Okay.
That's what I thought.
Yep, that's what I put. There's no calculating or anything. It says O, and then it says by American, so it's 0.45.
Sweet. So the next one says, what is the probability that a random selected person will not have type O blood? That's just the other 65%, or sorry,
55.
55%.
Yep, that's what I got. Is that what you got too?
Yes.
Okay, cool. Next one.
All right, so it says Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the 6 samples came from a patient identified as a bladder cancer patient. If the dogs guess at random, what is the probability that they will correctly identify the dish specimen with the bladder cancer patient? Would that just be 1/6?
Yeah, 0.143. Yeah, that's what I got. As divided by 1/6.
1 divided by 6? We got 1.6 or 0.167.
I got 0.143. Got how I got that.
I got 0.1666. Repeat.
Yeah. If there were 6 samples, 1 had it. 1 divided by 6 should be 1.
But there's 7. There's 7 bowls though.
Oh, okay, it is 1/7.
Oh, it has to be 1 divided by 7 then.
Yeah, that is correct. Never mind. Yeah, so 6 samples didn't have it. 1 did. 7 in total. Okay.
Yep. So it's 1.428, but you have to round it, so it's a 0.143.
Right.
Thank you. I was thinking 6.
Yeah, it's 7 bowls, so that's why. That's why that.
You're right.
That's what I got.
Okay.
Cool.
Question number 7 says, in a combined total of 54 trials, the dogs correctly identified the specimen from the a cancer patient 22 times. It is very unlikely that a dog would do well by random choice alone. Which of the following statements is most appropriate? This provides strong evidence that the dogs can detect bladder cancer. This is little evidence that the dogs can detect bladder cancer.
I put the first one.
Yeah, I was going strong.
That's pretty good for out of 54, 22 of
41%
them.
of the time.
Yeah, it's still an F, but that's pretty good. Still,
Oh, yeah.
detecting cancer, but
No, I can agree with that. Especially since it was random and it wasn't placed specified every time. Okay, all right, we'll go to next question 8. So M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table. Okay, if you reach into a bag of plain M&Ms, what is the probability of drawing a red colored candy?
it says right on it, so it's 0.13.
That's what I'm going with.
I don't want to think too hard on it.
Yeah, it's just because green. Yeah, I guess that's true. I wouldn't want to think too hard because it only adds up to 84% of the total 100.
Correct. So that means that green has to be 0.16 because that has to all add up to 1.
Yeah.
Which is one of the following questions.
Yep.
Oh, really?
Yep, number 9. So that would be 0.16.
Okay, number 10. What is the probability that a random selected candy is not green? 84% or 0.84.
Yep.
Does it matter if you do 0.84 or?
No, it doesn't matter. You just have to at least put a point in there. So you can put 0.16 or 0.84. That's fine. You just have to make sure there's a point before it. I like to because some of the tests I've done, it won't say that point is an actual number. So I usually put 0 point. So just to have that ones to be actually there. So.
Okay. All right. So last questions, or number 11, the ACT scores of students admitted to a medium-sized public university in the Western United States were taken from kpix.com. The following summary statistics were calculated: mean, standard, variance, minimum, Q1 median, Q3 maximum, and interquartile range.
So I'm guessing it's going to be the median myself.
That's what I thought.
So I'm guessing it's going to be 24.
Half of the observations are less than or equal to what number?
I'm guessing probably they're talking about the median. That's just me thinking out loud.
I mean, that's pretty much the definition of median.
Yeah, that's what I'm saying.
So, yeah.
I'm going to go with it. I'm going to lock in those lyrics.
Okay, based on the information above, the top 25% of the students scored above what number?
So that would be the third quartile.
Right, 27.
Correct.
That's what I'm going with.
Okay. Which of the following statements is not one of the 3 rules of probability? The probability that one outcome will not occur is 1 minus the probability that will occur. The probability is the number between 0 and 1. If the probability is high, then the probability is positive. If the probability is low, then the probability is negative. The sum of the probabilities in any probability is 1. Okay, so it would be that the third one I said.
Yeah.
Yep.
So if the probability is high, or it's positive, and if it's low, it's negative, it's not true.
Correct.
All right. Well, let's see.
Submit it. Oh yeah, I got 100%.
Sweet. All right. So Lester, what is the best way I can get the link to you or that works?
It worked. The mic on my computer is having trouble, so I'm trying to use my wife's, and I couldn't get the link to her computer. I was typing it wrong for some reason.
Oh,
And my computer seemed to work fine today, so I'll just use it.
okay. All right. Well, any other questions then?
No, I'm good.
I'm good.
I apologize for holding you guys up.
You're fine, man.
No worries. James, did yours end up coming up or did you just write them down?
No, I just wrote them down. Mine's just showing a black screen. This Hangouts, I think, takes all the
Bus?
data or whatever from
Yeah, the
my
Wi-Fi.
yeah.
Bus up, yeah. Well,
And then-
if for some reason you get one wrong, just message on that Hangouts that we have, and
Yep.
Okay.
I can go over it with you. Or I can go over it with you to make sure you get those all right.
And then also,
Sounds good,
I
thank
might
you.
I might not be here Thursday. Like told the rest of the guys that I'm going to go into my workshop and I got some stuff that's going to come up. Going to make new triggers and all that for FFL. So
Okay.
yeah.
Good. Have fun.
Oh,
Sounds good. All right. Well, I'll go ahead and end the streaming, and you guys have a great night.
Great.
all right. See you guys.
See you Thursday.
See you Thursday.